Hello guys, welcome to the second section, Machine Learning Terminology for Model Building and Validation. In this section, we will start with linear regression versus gradient descent. After that, we will see machine learning losses. Next, we will see train, validation, and test data. Then, we will look at cross-validation and grid search. Finally, we will illustrate the machine learning model. Now, we move on to the first video of this section that deals with linear regression versus gradient descent. In this video, we're going to take a look at analogy between statistical modeling and machine learning. In statistical modeling, linear regression with two independent variables is trying to fit the best plane with the least errors, whereas in machine learning, independent variables have been converted into the square of error terms and optimized based on coefficient values rather than independent variables. Gradient descent is a way to minimize the objective function j of theta parameterized by the model's parameter, and by updating the parameters in the opposite direction to the gradient of the objective function with respect to the parameters. The learning rate determines the size of steps taken to reach the minimum. In full batch gradient descent, all the observations are considered for each and every iteration. This methodology takes a lot of memory and will be slow as well. Also in practice, we do not need to have all the observations to update the weights. Stochastic gradient descent method updates weights by taking one observation at each stage of iteration. This method provides the quickest way of traversing weights. Mini-batch gradient descent is a trade-off between huge computational costs and a quick method of updating weights. In this method, about 30 observations will be selected at random and gradients calculated to update the model weights. Let's make a comparison between applying linear regression in a statistical way and gradient descent in a machine learning way on the same dataset. First, we need to import NumPy and pandas. Now, we will read data using a pandas data frame from file mtcars.csv file that we have created. We will then convert data frame variables into NumPy arrays in order to process them in scikit-learn packages, as scikit-learn is built on NumPy arrays itself. Next, we will import linear regression from the scikit-learn package. This works on the least squares method. After that, we will fit a linear regression model on the data and display intercept and coefficient of single variable using the print command. Now, we will define the gradient descent function gradient descent with x, that is independent variable, y, that is dependent variable. Learn rate, that is the learning rate with which gradients are updated. Too low causes slower convergence, and too high causes overshooting of gradients. Batch size is number of observations considered at each iteration for updating gradients. A high number causes a lower number of iterations, and a lower number causes an erratic decrease in errors. Max iter is maximum number of iteration, beyond which the algorithm will get auto-terminated. After that, we will calculate mean square error. Squaring of error has been performed to create the convex function, which has nice convergence properties. These lines of code run the algorithm until it does not meet the convergence criteria. After that, we will calculate a new error with updated parameters in order to check whether the new error changed more than the predefined convergent threshold value. Otherwise, stop the iterations and return parameters. Now, these lines of code describes gradient descent function with defined values, such as learn rate as 0.00003, convergence threshold as 1e-8, batch size is 32, and maximum number of iteration as 1,500,000. Let's run it. The output is returned as displayed. Now we will go to the R Studio. Here is the R code for linear regression versus gradient descent. Let's run it. We will get iteration, optimal intercept, and optimal slope in our output. In this video, we have learned linear regression versus gradient descent.